टॉपिक ऑफ दिस इज लिक्विफिकेशन. स्टेट्स ऑफ मैटर का नेक्स्ट टॉपिक है लिक्विफिकेशन ऑफ गैस एंड क्रिटिकल कांस्टेंट. ठीक है. Most of gases behaves like ideal gases at high temperature. Most of gases behaves like a ideal at high temperature. मतलब real gases behaves as a high temperature. For example, the PV curve. अगर हमने पहले स्टडीड किया हुआ PV का कर्व देखा तो अपने को दिखेगा PV curve of CO2 gas at 50 degree Celsius is like the ideal Boyle's law curve. इसका जो कर्व दिख रहा है CO2 गैस का, it is like ideal. It is showing ideal behavior. As the temperature is lower, as temperature is lowered, the PV curve show a deviation from the ideal Boyle's law curve. है ना. At particular value of low temperature, the gas is liquefied at certain increased volume of pressure. For example, CO2 gas liquefied at 38.98 degree Celsius and 73 atmosphere pressure. This is the highest temperature at which CO2 can exist. CO2 as liquid can exist. Above this temperature, pressure, whatever may be the pressure, liquid CO2 cannot form. Liquid CO2 cannot form. Other gases also show similar behavior. The temperature above which a substance cannot be liquefied. Substance मतलब a gas cannot be liquefied by increasing pressure. Is called critical temperature. Is called critical temperature. The molar volume at critical temperature. Molar volume at critical temperature is called critical volume. Is called critical volume, VC, and the pressure at the critical temperature is called, and at that pressure is called critical pressure. critical pressure of the gas. These values of three critical constant for the same common gas. ठीक है. कुछ एग्जाम्पल अगर हम देखते हैं तो अपने को दिखता है कि N2 and O2 have critical temperature values much below 0 degree Celsius. Much below 0 degree Celsius, and their critical pressure are high. Consequently, liquefaction of O2 and N2 requires compression and cooling. Requires compression and cooling. Requires compression and cooling. So we can say that critical value of CO2, critical value of CO2 nearly equals the room temperature. However, critical pressure is very high. Therefore, CO2 exists as a gas under ordinary condition. As gas under ordinary condition. अगर हम बोलते हैं कि वाटर हैज़ क्रिटिकल टेम्परेचर 647.1 Kelvin and critical pressure equal to 220.6 bar. What do these values gives information about the state of water under ordinary condition? State of water. State of water under ordinary condition. Ordinary conditions. तो हम लोग बोल सकते हैं कि अगर हम बोलते हैं कि वाटर हैज़ क्रिटिकल टेम्परेचर 647.1 and pressure equal to 220.6 bar. What do these values gives information about the states of water? States of water under ordinary condition. Under ordinary condition. Critical temperature and critical pressure. Values of water are very high. Values of water very high. compared to the room temperature and common atmospheric pressure, compared to room temperature and atmospheric pressure. Consequently, water exists in liquid state under ordinary condition of temperature and pressure. So, water exists in liquid state under ordinary condition of temperature and pressure. टेम्परेचर एंड प्रेशर. हम लोगों ने जो कर्व निकाला था पिछले लेक्चर में, वो कर्व क्या बता रहा है अपने को? पीवी कर्व्स फॉर वेरियस गैसेस एट डिफरेंट टेम्परेचर रिवील्स that under certain condition the substance changes completely from gaseous state to liquid state. Under certain conditions and under ये बोल सकते हैं हम लोग अंडर सर्टन कंडीशंस water any substance changes completely from gaseous to liquid state or from liquid to gaseous state without having the coexistence of two states coexistence of two state. In other words, there is a continuity between the gaseous and the liquid state. Continuity is recognized by using the term fluid for either gas or liquid. Under this condition, liquid is just very dense gas. It is very dense gas. Liquid and gas can be distinguished from each other only when the fluid is at a temperature below critical, है ना. सो हम लोग एक इम्पोर्टेंट स्टेटमेंट करते हैं. लिक्विड एंड गैस कैन बी डिस्टिंग्विश only when fluid is at a temperature below critical. Fluid is at a temperature below critical temperature. When liquid which is exposed to atmosphere is heated, its vapor pressure increases. It becomes equal to the atmospheric pressure. At this temperature, the vaporization takes place throughout the bulk of the liquid and the vapor form escape freely into the surrounding. This is called as the boiling point of the liquid. Next topic we can discuss about the boiling point.